Okay, hello and welcome to the programming lecture. This is going to be very, very cool. I can promise you that. So we're going to talk about what is called turtle graphics in Python, and we're going to draw stuff with a turtle. It's going to be amazing. Okay, are you ready? So first, let us talk about getting input. Okay, that's eventually going to be necessary. It's the one last thing before the turtles, I promise. Okay, so we're going to ask the user, let's do this example. Let's ask the user for two numbers, and we'll compute the first number to the power of the second number. And powers in Python is just the double star. So we need to get two numbers, like, I don't know, num1, 2, maybe these are type 2, and then we get num2. We need to get 3 here. Okay, so that's all we have to do. Compute 2 to the power of 3. Isn't that so difficult? So I do want to warn you that our programs, yes, they're going to be a bit simpler right now. Obviously, this is kind of a simple idea, but we have to learn another language right now, okay? All these things that we knew how to do in Scratch are not the same, okay? In general, I say, it takes a bit more code to write a program in Python, the same program in Python, compared to the equivalent one in Scratch. And we say that Python is a bit more low level, that's the word, and Scratch is a bit more high level. Okay, so we're going to need this in a second, but let's get there. Okay, so let us use input. You remember your input function? It'd be like input, ask for number, enter first number. Colon space, for example. And we can assign that to be like, that can be our num1, yeah? So let's get started. Let us open up Python, idle, and I made a little empty file here. Let's call it powers, I guess. And we're going to save it on my desktop in code from class, CSCI1. This is lecture. I'm going to assume that it's lecture 14. There we go. And let's call it inside of there. Let's call it powers.py. Okay, so what we're going to do is ask for two numbers and then compute the first number to the power of the second number. Yeah? So num1 equals input, and then we give like a little prompt. Enter first number, colon space. And then we'll have num1, and then we'll do the same for num2. Yeah? Enter second number, please. And we'll call this one num2. Okay, and then we should have them, right? We should be able to like print out exactly what the user gave us. Print num1, print num2. That's totally fine. And if I run this, let's see what happens. So it's going to execute this code. It's going to be like, all right, I'm ready. Enter the first number. 42 and 3. And hey, it got them. Num1 contains 42, num2 contains 3. Or in my example, we can give it 2 and 3. 2, 3. It got the 2 and the 3. Now all we have to do is get the num1 to the power of num2. So it should be as simple as num1, or let's just print it out. Num1 to the power of num2. Yeah. That shouldn't be too bad, right? Right. Let's run this. 2, 3. Ooh, we get an error. Line 7, which is this line. You can see the line number way down here, very small. Let's see if I can zoom in for you. Oh, that was a little too far. There, way down here, we have a line number. Okay, if you can see that. Line number. It tells you what line you're on. That's going to be important for the error messages. Yay. Okay, we're done with that. Unsupported operand types for power. Stir and stir. What's our num1? It should be 2, right? Oh shoot, it's the string 2. Yeah, I was trying to do 2 string to the power of 3 string. Those aren't numbers. Aha! We can fix that. So we can convert. We can say we can make an int out of a stir. Okay? All we have to do is say int, pretend it's like a little function, and give your number inside of it. So int 42, the string, gives the number 42 back. Ooh, yes, yes, yes. We like that. We like that a lot. So int of num1 gives us back the actual number 2. You see that? That's quite useful. So let's take advantage of that. Let's convert num1 to an int, and then store that int right back. This is weird, but I'm going to do this. num1 equals int num1. So it's first going to convert it to an int, and then save it back in num1. Okay? That's the idea. Let's do the same for num2. So now, num2 equals int num2. Now we can print out that power. num1 to the power of num2. Now this will work, because the types are correct. Okay, so let me run this. 2 and 3. Ooh, yes, 2 and 3 strings, but 8 the number. Okay, so num1, it used to be a string, but we converted it to a real number because we did num1 equals int of the old num1 that was a string. Okay, I hope you see that. So it's converting it. It's doing this right-hand side first, and then making it back into num1. Okay, so that is it. We can be a bit fancier if we would like. It'd be like num1 to the, and remember you can use double quotes or single quotes for your strings, to the power of, and these commas put spaces in for us, num2 is that. That's a bit fun. So 2, 3, excuse me. It's like 2 to the power of 3 is 8. Isn't that nice? So that is, that's my first example for you. Okay, so yes, type conversion is very important because strings can only do some things, ints can do others. Okay, so now we're ready. We're ready for the turtle library. Can you believe it? We are here. So if you double click this link, or just click it once with a control or something, it takes you to this page, and this is going to tell us all about how to do turtle graphic things in Python. Okay, we can make pretty pictures. Let me show you how. So the idea is, there's a metaphor going on here. A fun little programming language in like the 70s called Logo was the first to do this. But the idea is, there's a turtle. Okay, I don't know, he's over here. And, or maybe we should talk about how he got there. Okay, there's a turtle, and his tail, for reasons unknown to us, it just happened, somehow he got his tail dipped in ink. Okay, unfortunate, but good for us. And he is a trained turtle. Okay, he can move wherever we ask him to. He knows what directions to go to, and we can ask him to move in any of them. Okay, so the turtle is trained, and we can tell him to put his tail up and down, like, hey, start writing stuff, hey, stop writing stuff. And so down makes marks, because it's down on the paper, and then up does not. It's like holding it up so that he doesn't get the ink on the ground. Okay, so the turtle can draw whatever we would ask him to, because he had his little tail dipped in ink somehow. Okay, here's my best drawing of a turtle. Little shell, little turtle, little tail. That's a horrible turtle drawing, I know. Actually, his head like supposed to be right there, isn't it? That's how a turtle looks, isn't it? I think. That's better. Okay, that's the idea. He's got a tail that was dipped in, apparently, blue ink. Okay. All right, that's the turtle library. So let's use this fact to our advantage. Let's use our turtle to draw a square. Okay? So let's do this. Okay, so I'll do a draw square file. So we'll call this drawSquare.py. And what you do, the first thing that you need to do is import the turtle library so we can actually use the turtle, okay? Because that's where all the stuff is coming from. The turtle lives in the turtle library. Okay. Okay, and so now we have access to our nice, beautiful turtle. All right, so let's see. I think if I run this right now, it's not really going to do much, is it? Yeah, I have to actually use the turtle. Okay, so here's what we do. Dun, dun, dun. the idea is the turtle's going to start out in a window. It's going to make a window for us, and the turtle's going to start out pointing east. Okay, so the turtle's facing that way. Like if the turtle were a little arrow, he would be facing that way. And if we told him to go forward, he would start moving. Okay, he would start moving in that direction to draw a line like that. Okay, so maybe if he came from over here, he would draw a line that way if he moved forward. So let me make him move forward. Let me show you that, at least. Boop. We can say turtle dot forward, and then we give him the amount that we want him to move forward in. Okay, so maybe like, hey, move 50 forward, 50 units forward. In your current direction. The turtle's facing some way, and we're telling him to keep going. Okay? And he starts out, you can see him, he's way down there, he's tiny. He's facing east. Okay? Oops. Whee. So that was what our turtle drew. He drew this line, and him, the turtle itself, is this little arrow, which is no fun. Let's make him look like a real turtle. We'll do that in a second. But let's talk about this. The idea is we're controlling the turtle with a bunch of turtle dot things. Okay? Turtle dot position is the next thing I'm going to show you. And the idea is the library functions kind of belong to the turtle. Okay? So we're like asking the turtle with the dot, like turtle dot, do this for me, please. Okay? So turtle dot position, for example, will give back the turtle's coordinates. So let me show you that the turtle starts out at 0, 0. Turtle dot position gets his coordinates. Okay? Whee. And so it gave back 0, 0 to us. So that was the middle of our little screen. Okay? And maybe we want him to move even farther forward, like move 150 forward. And so then he went that way by a large amount. Okay, so that is how you do stuff. And you can see all this stuff, all the different things that you could do to a turtle in this file. So I encourage you to take a look at it all. So what we just did was use position, and it gives back the turtle's current position, x and y. Okay? And then I've also shown you forward. So where's that? Move and draw, most likely forward. FD for short, if you wanted to use it that way. You can do forward and then a distance amount. How far do you want him to move forward in the current direction that he's going? Okay? So that's all nice. Dun dun dun. There's forward, and let's do a few things. Okay, so the first thing that I want to do is make him actually look like a turtle. So let's do that. Dun dun dun. There we go. So shape is something that you can use on turtle. Dun dun dun. Where is he? Appearance. Yes, shape. Shape right here. If you do turtle.shape and give it the string turtle, he will actually look like a turtle instead of a little triangle, a little arrow. So you can say turtle.shape. Turtle the string. So make the turtle look like a turtle. And I guess I changed this to 150, didn't I? Boop. And now he's a pretty turtle, okay? So now he moved right. He moved in his current direction, which was east, exactly 150. Okay, so we're going to make a square now. And the idea is we want him to, yes, move that way 150, but then we need him to turn so they can move this way 150. Right angle. So if he's facing this way, and we want him to turn to be this way, we need him to turn to the left 90 degrees. Okay? 90 degrees to the left. And there's a nice, there's a nice function on turtles that has him turn a certain direction by a certain degrees. Okay, so it's called left. So there's also right, of course. So turtle.left turns left by a certain number of angles. So we can say turtle.left 90 to make the turtle turn left 90 degrees and be sitting right here ready to go straight again. So let's do that. Turtle.left 90 degrees, turn left 90 degrees. And if I run this, I keep doing F5, but I can do this as well. You can see how he's ready to go forward now, and he'll be almost, he'll be pointing in the right direction. He's almost ready to like actually go and do the thing, okay? So if we can just keep moving him forward now, go forward the same amount, we'll have a square. Now we have two sides of the square, yeah? And now we need him to turn to the left again, yeah? Turn left 90. I think you can see where I'm going with this. Turn left 90, and then once you've done that, yes, save please, go forward some more. Forward 150 some more. You can see if you do this a bunch of times in the right order, turn left 90 degrees again, turtle, he'll actually draw a circle. Or, sorry, not a circle, but a square. Turn left 90 degrees one last time, and then go forward 150, the same amount. This will give us our square. Ready? He did it. And now if we made him go forward any more, he'd go off this square. That's the idea. So he just made a square. Isn't that fun? So that's our first turtle graphics idea. How about two squares? What's better than one square, but two squares, right? So let's draw a second square a little ways away. Maybe we can do it down here. That's fine. What we need to do, though, is pick the turtle up, because if we don't pick the turtle up, he will do this. It's like, ooh, move there, and then draw your square. Ooh, we'll keep this silly line, yeah? We need to fix that. Let's make another. I'll make a new file. 2 squares .py. Close this one. Now, what can we do? Need a square, let's make another. So turtle dot forward, I don't know, let's do it 100 distance down, because he's currently facing down. And the issue is, he drew a line there. We didn't want that line. We gotta pick him up. Pick up the turtle so that he doesn't draw extra lines when moving. Okay? And you do that with turtle.up. Okay, I think pen up also works as well. Where is that? Dun, dun, dun. So yeah, we have pen up, or PU, and pen down, or PD, or down. Okay? I think I'll just use up and down. So any of those work. It pulls the pen up, or pulls the pen down. So it's a little tail. So I'll say turtle dot up. So now he won't draw when he moves forward. Okay? Yeah? Very nice. So now he's just over here, and he's got his tail up still. We need to set that tail down if we want to draw a square again. Okay, now we can put the tail down. And now he'll make actual things again. Okay, so we don't want that part right there. And so another thing that we can use to quickly get a turtle pointing in the right direction, because we liked drawing our squares when he was initially pointing east, we can say turtle dot, I think it's set heading, or just heading. Let's see, which one? Yeah, it's heading. Dun dun dun. No, it is set heading, sorry. Set heading or set H. There we go. And so this will set the heading, or the angle that the turtle's facing, to whatever angle you give. Okay? So set the orientation of the turtle to wherever you want. And so 0 is east. Alright, so we can say turtle dot set heading, or just set H. It seems like both of those work. 0 to do 0 degrees, which is facing east. Yeah. All right. So facing to the right. That'll work. We'll say turtle set heading 0. And so now he's over here and he's ready. He's ready to draw a square. Let's do it half the size, like 75. So we'll do forward 75. And we can turn left again by 90 and do it all over again. So turtle.left 90. And I think you can imagine if I do this a few times, it'll work. Boop, boop. Don't need that last one. Okay, forward, left, forward, left, forward, left, forward, left. Yeah? So now I have 2 squares. Life is good. It is a good day. Okay? So that's 2 squares. What about, I don't know, a triangle? How about a triangle? This one's going to be fun because now we have to pick the real angles. We can't just say left, 90, that one was easy. Let's draw an equilateral triangle. Okay? So, everybody's got the same amount of sides, of the same length. Sure, sure, sure. This one's going to be interesting. So let's pretend our turtle starts here. We can draw a triangle pretty easily. Like, I don't know. We can draw the bottom part of the triangle pretty easily if it's a triangle like that, if it wasn't rotated or anything. But if we want an equilateral triangle, we need to figure out what we're doing here. That's my best drawing of an equilateral triangle, sorry. The idea is all of these are the same size, right? Same width, and also same angles. Boop, 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 and boop, boop. What is that angle? If it's equilateral, they should all be the same, right? And so a triangle has 180 degrees on both sides, or on all the sides. This should be 60, yeah? And these should all be 60, and we have to pick that to make sure of that. And different triangles have different degrees, right? If we were doing an isosceles triangle, it would look a bit weirder, yeah? That is the idea. So that is an equilateral triangle. Let's figure this out now. Let's figure this out. So the idea is go straight. Go straight by the size, whatever size we want this triangle to be. Maybe it can be a 200 size triangle. How about that? So let's copy some of this, make a new file, and we'll save it as draw triangle.py. Okay. What can we do here? Oh, one thing I forgot to show you. Sorry. I think I wrote it up here, but I just glossed over it. Where was it? Turtle.speed. I forgot to show you turtle.speed. Excuse me. So let's do that right now. So the turtle, when you draw really fancy things, you might get really bored or mad at the turtle that he's moving pretty slow right now. You can make him move faster with turtle.speed, and you can give him either strings or numbers. You can say fast or fastest or normal or slow. I think he's set to normal right now, so we can make him fast if we'd like. Dun dun dun. So you can say make the turtle go fast. Turtle.speed fast. You can also do fastest. So now he drew that really quickly. You see that? Sorry about that. Now we're all on the same page. Okay. So current speed's fine. Let's figure out how to draw this triangle. So we need to move to the right by a certain amount. Let's make it 200. Okay. So move east 200. That's fine. So turtle dot forward 200. And now comes the fun part. Because how do we make him face in the direction that he now needs to go? We need to make him face like he's facing this way. We need to make him face like that way, kind of, whatever angle that is, right? So it's 60 degrees. We're well aware of that. This is 60. They're all 60. But what in the world do we give to this turtle? Do we say left 60? Maybe we do. Turtle.left 60. Surely that's correct, isn't it? Then we can say turtle.forward 200, or maybe we'll just confirm. Ooh, that's wrong. You see how it'll go off in the wrong direction? It wasn't 60. What was it then? That's the wrong one. That's left 60, yeah. Makes sense. Because the turtle was facing this way. Left 60 is like, I don't know, he's facing this way. 90 would be this way, so 60 is somewhere over here, yeah? That's the idea. So it wasn't 60. Let's figure it out. It needed to be something else. We wanted to go that way, and we need to turn left to get there. So we really need to cover a lot of ground. We need to cover this much ground right here, which includes 60 degrees there. We need to move the turtle that way. What is the rest of this? That's 180 minus 60. You see that? Because this is a straight line. These need to add up to 180, these two angles. It's got to be 180 minus 60. Weird, huh? So just watch out for that. Geometry, you never thought you'd use it again, did you? So, not 60. This isn't enough. But more. But more, please. So it's, no, I guess I wanted it in the same spot. It's 180 minus 60. Which is what, 120? That's going to do it. Yeah. And then this will be the same amount. So you're just turning again, not by 60, but by 120, because we're turning left. Okay, we need to go even farther than 90 degrees to get to the right spot. Okay, it's a bit unintuitive, but now that you've seen it, I think it'll make sense. So that's our triangle. Fun, huh? Okay, so that's our nice triangle, equilateral triangle, very easy. What else can we do? What else? And what I'm about to show you is good practice for your next programming assignment. So I'm going to draw my initials, okay? So I'm going to draw LN, because why not? I'm going to try and draw LN on the screen. L is easy, that's like a box, right? But the N is going to be hard. Let's figure this out. Let us figure this out. So, what can we do? Maybe we'll give ourselves some space. Let's first do that, of course, because we don't want to, like, be forced to only draw things like starting here, there's my L, there's my N. Let's go backwards a little bit. Let's be like, let's do it in the middle. Be like, let's move the turtle back a little bit so that way it can do the N over there, and the L right there. Yeah? Let's move back a little bit first. So, just like there's forward, there's also backward. You can totally use backward. Just goes backwards. Why not? Let's do it. New file, my initials, .py. And now, can I do this? Let's do backwards, okay? Let's move a little bit to the backward direction. I don't know, 150 backward? Why not? And again, the problem is, he's backing up. And sadly, he's also making marks. So we got to put him up first. Pick your tail up so that when you move backwards, you don't draw the line. Much better. And now we can draw our L. Okay, so L, let's say like this is 200. Let's try that at least. Let's try it being 200. Or you know what? Let's draw it out. Huge. This will be 200. And so we got to get our turtle facing that way, which is, I guess we can go right 90. That would work. Please turn right 90 degrees, turtle. So now we should be ready to draw the L. He's pointing straight down. Okay. So let's do a 200 length L that way. So we need to move down 200. Oh, sorry, not down 200. I was getting ahead of myself. Turtle up forward 200, excuse me. And what did we forget? We forgot to put him down, right? turtle dot down, turtle dot forward. Yeah? Very, very nice. We did it. So, that'll work. Then let's move over. I should say this. Let me write this so that I remember to say it. I'll say it soon. Okay, so now turtle's right here facing that way. We need to move him that way. That is left 90. Yeah? Hey, and now we can go straight a certain amount. What is that? Let's try and like eyeball this. It's like 125, I don't know. Let's try that. Let's try like 125. That can be the width of our little characters here. Why not? So now let's go forward. 125. And I keep pressing F5, but of course you know how to run it, right? Hey, that looks like a reasonable sized L, right? And now we need to get ready to make the N. N's going to be over here. So, notice, first of all, if I could draw a straight line, notice that there's some space. Hoo. That's no fun. That's going to be a pain. I would also like that to be 125. You get the idea. So we need to have some blank space. Ooh. Maybe that can be like, I don't know, 40 blank spaces. And so we need to pick the turtle back up. You see the game you have to play here? Turtle dot up and turtle dot down. All over the place. Let's do turtle dot up, and we'll go forward 40. There we go. And now we're ready to do the N, so we should put the turtle back down. Now the N will be fun. This first line is easy. Let's do that one. That's just okay. We're facing this way. We just gotta move left 90 degrees, and then we're ready to go. And then we go 200 straight up. We're going to make these letters be the same size, of course. That's the L, there's the N. Okay, first line of the N. Now comes the hard part. Are you ready? So maybe I should use a different color because this is going to be weird. We need to figure out this angle. Okay? Let's assume that this is also going to be 125 width here. The width can be 125, that's fine. We need to figure out this angle right here. What in the world is this angle? Question mark. That is going to be unfortunate. That's going to ruin our day. And let me draw this a bit cleaner. Boop. I need to make a straight line to there as best as I can. There we go. A straight line up. Okay, so this angle, what in the world is it going to be? Okay, so this is where our trig comes into play. We know this is 200. This is 125. And this is the angle we want. What do we got? We have the opposite and the adjacent. Ooh. You remember your SOHCAHTOA? We have tangent. We know that tangent of our question mark angle is equal to 125, the opposite over the adjacent. 200. Oh man. Isn't that fun? So we can figure out what the question mark is by doing inverse tangent. Okay, question mark equals inverse tangent of 125 over 200. And that will give us this whatever angle it needed to be. Okay? And we can use variables to keep track of this, because that's going to be fun. So let's go to our math library in Python. We're going to need that now. Table of contents, math. There we go. Oops. Math. We have, let's see, we're going to need tangent. But not just any tangent, inverse tangent. Here we go. Trigonometric functions. It's a tan. That is the inverse tangent. Okay? Are you ready? So we need to figure out this. The inverse tangent of 125 over 200. So let's just call it the weird angle in the end. So angle equals math.atan, and because we're using math, we have to import it. Math.atan 125 over 200. Yes? So that is almost the right answer. Let me show it to you now. So we're going to calculate it. It thinks that the answer is this small number, and that is not what we want, right? That's not an angle value, that's a radian value. So we need to convert from radians to degrees. There we go. And so math.degrees will fix that for us. It will convert from radians to degrees. You give it the x radians, it will make whatever that was in degrees. Okay, so that's the last thing that we need to do, is also convert to degrees. Okay, we're almost there, we're almost there. We do angle equals whatever it was, but math.degrees. See if that looks better. Ooh, it's almost 32 exactly, 32 degrees exactly. So that's our angle. It's 32 point whatever. Oops. 32 point ... Awesome. How can we use that? Well, remember that our turtle, this is hard enough to draw. Let's go over here. Remember that our turtle's facing this way. We need him to face this way, which is not left 32 degrees, but left, what? Dun dun dun. So he's facing this way. We need him to face this way. That is 180 minus 32, okay? It's again that same problem. We gotta go 180 minus this to turn. Okay? So that's 180 minus angle, or question mark. There's a lot going on here, I know. I'm sorry. This is just the price we must pay to write Python. Okay, I'm gonna show you a trick though, a cheating way to do this later. Okay, so we're going to turn, what was it? We need to turn, we're going this way, we need to turn to the right by 180 minus our angle. Okay, so now he's ready. He's ready to draw that in. Yes, 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 yes. Now you need to go straight. Oh no, how long? How much do you need to go straight, turtle? How do you, oh no, oh no. We need to figure out what this is as well. That's another question mark. What is this length right here? What in the world is that? I don't know, how do I draw that? That length right there, what is that as well? Oh no, question mark number 2. That length, again we can get through geometry. Okay? Again we can get through geometry. It's whatever. Are you ready? I'm so sorry. It's we need the hypotenuse. We need the hypotenuse, and we have both the adjacent and the opposite. We can use either sine or cosine. Let's just use sine. Sine is opposite over hypotenuse, so sine of question mark of the angle that we have now equals I don't know, sine of angle 32 degrees, whatever it was, equals opposite over our hypotenuse, 125 over our question mark number 2. So in order to get that, we get 125 times sine of 32. Okay, that's the length that we need now. So I'm going to write this in code. So now calculate this, the length, is going to be equal to 125 times math.sine of our angle. But it's not this angle anymore because we converted it, right? We converted this angle to degrees, and sine needs radians, so we need to go through radians again. So convert it back to radians. And that is our length. Let's print the length. See if that looks good enough. It should be longer than 200 if we did it right. Oh shoot, it's 66. What is wrong here? Oh, oops, I'm so sorry. I solved this the wrong way. I'm sure you were yelling at me through the screen. I apologize. It's been a while. So, it's not times, because this is on the bottom. Oops, I'm still erasing. It's on the bottom. No, no, no. Let's move you over here. Sine of 32. We got to do some weird math, right? We got to like bring this over here and then divide by that. So it's 125 over sine of 32. Oh no. Come on. That is my fault. Maybe if I were better at lying, I would have said, "Oh, that's a bug." Where was the bug? But we found it. Okay, so it's 125 over the sine of 32, not times. Excuse me. So that should look more like the number we need. Yeah, that's more than 200. I'm happy with that. And then we go forward by that amount. Okay, so I say forward by that. Bam. And now we're almost home free. And now we go this way. You go that way again, which is not 32, but 180 minus 32. And then we can go 200 up. Are you ready? Dun, dun, dun. So it's not right anymore, is it? It should be left. Yeah, because we're going that way. We need to go this way. So we need to turn to the left. So not left this time, but not by the angle. 180 minus that angle. Yeah. All right, so now we're ready. We're finishing touches. You know what to do. We're going up 200. We're there. We did it. And that, my friends, is geometry in action. We did it. We have drawn my initials. And now I want to show you a cute little trick that you never needed to do this with, okay? You never needed to do what I just did. I'm sorry, you're welcome, but what you can do instead is, oops, on the turtle library, there's turtle.goto. Dun dun dun. Turtle.goto, okay? Or set position or set pause. Goto works for me. You can say turtle.setPause or turtle.goto, and then some coordinates, okay? You can say turtle.goto, x value, y value. So if this was like, I don't know, bam, if we were right here, and this was like, I don't know, 100, 0 or something, we could just go down here, which was length, I don't know, 100 plus 125, so that far over in the x direction, and then 0 minus 200 in the y direction. If we just went there, like turtle.goto this coordinate, that's hard to write, I don't know. Where can I write this? Turtle.goto x comma y. And I'll just pick the turtle up and move him straight there without having to worry about directions. Okay, so you can cheat with that, and that might make your next programming assignment a bit easier. So I wanted to show you the hard way, though, because it is possible, and that's really good programming practice. So now I'm going to pull up your programming assignment, and I'll be right back. Okay, here we are. Here's your programming assignment. And what you're going to do is you're going to draw your own initials. Okay, you're going to make a Python program following mine. Of course, I'm going to give you all this code, of course. And you're going to draw your own initials, and then also I want you to draw some numbers too, your graduation year. Okay, so please write a Python program that uses turtle graphics to draw your initials and also the year that you intend to graduate. So for me, I graduated from the last possible degree I could get in 2020, so I would do LN20, yeah? So that is what you will draw, and you don't have to do the fancy angles like I did. If you're having trouble, don't worry. You can do it like you can just do a bunch of straight lines if you need to, just get it working. So here is my initials from class, and don't forget to write the 2 digits of your intended graduation year as well. Okay, so if your name has an L or an N in it, you're welcome. Everybody else has a bit extra work to do. So yeah, that's what I want you to do. So just draw your initials and then also your graduation year. So some letters and numbers. Okay, so hopefully that'll be fun. And as usual, upload a video of your programming running and explain your code to me. Okay, shouldn't be too long, shouldn't be too bad. Please yell at me if you have any questions. That is what I have for you. So that's your next programming assignment. So good luck with that, and I will see you later.